This is problem number 4 from the sample test problems for test number 3. Describe the end behavior of g of x equals 5 cosine e to the minus x as x goes to infinity and as x goes to minus infinity. Clearly explain why g exhibits this end behavior. Hint, do not trust a calculator-generated graph for negative values of x. In fact, I'm not going to trust the calculator for anything on this problem, but maybe we'll look at it at the end. So let's first take a look, see if we can use good limit notation. Limit as x goes to infinity of g of x, that's the original. So that's the same as the limit as x goes to infinity of, and then I'll just write the formula, 5 cosine e to the minus x. And what's happening here is x is getting very big. And so if we make x really, really big, then the power is actually really big and negative. So I'm going to put here on the side, this isn't really like mathematically precise, but I'm thinking of 5 cosine of e to the negative infinity. And so really the question is, what can you say about e to the negative infinity? Well, I'd like you to be able to say something. E to the negative infinity, well, let's see. I mean, I believe the idea about negative exponents going downstairs, then that's 1 over e to the infinity. And e to the infinity is what kind of a number? Well, it's a really, really big number. And 1 over a really, really big number is what kind of a number? And hopefully we can see it's very close to 0. So ultimately, I'd like you to be able to say that this thing in the parentheses is going to 0. Another way to see that, if you think about the graph of e to the x, and you look on the graph for a place where we could find, say, for example, e to the minus infinity. So we're shooting straight left, and as you follow this curve left further and further and further, what y value do you approach? You approach y equals 0, same as we saw before. Okay, so that means that this must equal 5 cosine, and we decided the thing in the parentheses goes to 0. And now the rest of this is straightforward. 5 cosine of 0 is 5 times 1, so the limit on the right-hand side must be 5. And it doesn't ask for it, but we're going to check on the calculator what the graph of the original function looks like. That's this function right here. And we have just discovered that on the right-hand side, it gets really, really close to 5. So that means there's going to be some horizontal asymptote at y equals 5. Okay, and then how about we play the same game going the other direction? Limit as x goes to minus infinity. Practice with the notation. And now we'll copy the function. Limit as x goes to minus infinity of 5 cosine e to the minus x. And now we play the same kind of game. We're interested in finding out what's happening to the thing inside of the parentheses there. E to the minus x. We're really saying e to the minus, and then instead of x, we are sending x to negative infinity. So this x is going to negative infinity, which means that the whole thing, whole power, is actually going to positive infinity. E to the positive infinity, well, what kind of a number is it? I mean, it's really big. It's big fast. You can see it on the graph as well. As x goes to infinity, e to the x goes up forever. So the thing in the parentheses is really big, infinitely big. So I'm going to say this is kind of, limit as x goes to negative infinity, 5 cosine of big. And I say kind of because cosine of big doesn't have meaning, but you get the idea. And so what happens to the cosine function when the angles that you plug in get bigger and bigger and bigger? Well, let's think about the graph of the cosine function. So there's y equals cosine of x, and we are plugging in big, big, big numbers into the cosine. So we're plugging in big numbers, meaning go to the right forever with your x's. And what happens to the y values? Well, the y value could be 1 or 0 or -1 or -0.2 or positive 0.4 or up again at 1, and you can see that the y values are not honing in on anything. They're just bouncing up and down forever, oscillating infinitely often, and in a case like that, we say there is no limit. The y values don't approach any single number. So let's say the limit does not exist. Cosine oscillates infinitely often. So on the left-hand side of this graph, of this crazy equation up here at the top, I'm expecting to see the graph oscillate infinitely often. So we finished the question. I do want to say a tiny bit more. This isn't really what I'm after, but I know that it's kind of an extension here. I know that 5 cosine, all right, so cosine goes between -1 and 1. So multiply by 5 and it goes between -5 and 5. So I'm going to draw this dotted line here. This is not a horizontal asymptote at -5, but it's going to serve to trap my graph. I know on the right-hand side we are approaching 5. And I'm always between these two things, so I feel like if I graph the function, it's got to at some point do something like that. Get really, really close to 5 as we go to the right. If, for example, I were to plug in x equals 0 right here, just to plot a point, I'm going to get 5 cosine of e to the 0, 5 cosine of 1. Cosine of 1 is some number. Suppose we can use our calculator just to get a sense. We got 5 cosine of 1, 2.7. So if we plugged in 0, we get around 2.7. So somehow the graph is going to hit this point at around 2.7. And on the left-hand side, I'm expecting it to oscillate infinitely often. And so it's going to, I don't know if it's going up or down at this point, but I'm expecting it to do something like this, infinitely often. But in fact, I can say a tiny bit more. Again, this is just an extension here, but I know that the angles that I'm plugging into my cosine function are like e to the minus x. And we decided that that was going to be like e to the infinity. So every time you plug in an x that's, like x is -1 or -2 or -3, you're actually plugging in like e to the 1 or e to the 2 or e to the 3. So it's not going to oscillate like this purple thing where it just stays consistent with the period. I actually think it's going to oscillate faster and faster. If we're going to undo some stuff here. Expecting that it's going to oscillate, here, like that. But because E goes big quicker and quicker, I'm expecting that the periods are going to get smaller and smaller and smaller, which is why I think the calculator is going to have some difficulty graphing it. So let's just see how close we are here. So we're going to graph 5 cosine e to the minus x. And the window we want here, oh, I don't know. Let's just try the standard window and see how it looks. Zoom 6. Okay, there's the wild oscillations on the left-hand side. And then on the right-hand side, quite quickly, heads towards that horizontal asymptote at 5. I kind of want to see what's happening in here. I mean, it looks like it's not oscillating all the way up to 5 or all the way down to -5, like there's space in here. I think that's just a sort of glitch of the graphics. The calculator has only so many pixels it can show us. So what if we decided to look between, say, -2 and 1? And I'll just go ahead and close this up a little bit, -5 to 5. Okay, so that's kind of more of what I was expecting. It's got oscillations on the left-hand side where they're kind of spread far apart in the beginning and they're going to get closer, and we'll just play this game one more time. Let's try going to -3 on the left-hand side, and then you can see quite a few oscillations and then slowing down. And so as you go further and further left, it just kind of tightens up. And on the right-hand side, heads towards 5.